Hi guys, your Friendtor Gopika is here, and in this video we will learn some applications of Pythagoras theorem. Okay, now as I said in the note below, this particular topic is removed for SSC 2020-21. Okay, now we are facing this COVID-19 situations, and because of that, as you all know, 25% of the syllabus is removed from all the subjects for all the standards, okay, from 1st to 12th. In that, under that, for this particular batch or for this particular year, this topic, the applications of Pythagoras theorem, is totally removed. The exercise is also removed. So this is not important for the board exams for this SSC 2020-2021 batch, okay. But for the students appearing for some other exams or who want to proceed with mathematics in future, I would suggest that they watch these videos and they practice these problems, okay. So without wasting time, let's get started. Okay, applications of Pythagoras theorem. In the Pythagoras theorem, the relation between the hypotenuse and sides making right angle is what we learned, okay. That is the relation between side opposite to right angle and the remaining two sides. Hypotenuse means the side opposite to right angle. So relation between these three sides we actually learned. We learned that the hypotenuse, square of the length of hypotenuse, is same as adding the square of lengths of the other two sides, okay. Now in a triangle, relation between the side opposite to acute angle and the remaining two sides, and the relation of the side opposite to obtuse angle with the remaining two sides, that can be determined with the help of Pythagoras theorem, okay. Now here in Pythagoras theorem we were discussing about the side opposite to right angle and the relation with the relation of the side opposite to right angle with the other two sides. Now suppose the side is opposite to an acute angle, then what is its relation with the other two sides? And suppose the side is opposite to the obtuse angle, then what is its relation with the other two sides of the triangle? Those two things we can determine using the Pythagoras theorem. So let's see that. Okay, so this is the first example. Now here in triangle ABC, angle C is an acute angle. So if you see this particular triangle, it's a very normal triangle, it's not a right angle triangle. There, this particular angle C is an acute angle, which is, that means it is less than 90 degree measure. Now whenever you have such a triangle, you can draw an altitude AD, which is perpendicular to BC. Okay, so here you obtain two right angle triangles when you draw this, okay. Now we need to prove that AB square, now AB is the side opposite to this acute angle C, okay. AB square is equal to BC square plus AC square, that is adding the squares of the other two sides, and from that you subtract minus 2BC into DC, okay. So these are the things. Now in the given figure, let AB equal to C. Suppose the side opposite to angle C is that is AB is small letter c, okay, and length of AC is small letter b since it is opposite to the angle capital B, and AD is randomly given to be, let it be P, and BC, which is this whole thing, is A since it is opposite to the angle A, so this whole thing is small letter A. Now the half part of it, not the half part, this first part, the BD part is A. Suppose the DC part is X, then the BD part is A minus X, because BD is BC minus DC, so A minus X. That is how we have used some small letters to name each side or showcasing the length of each side, okay. Now in triangle ADB, by Pythagoras theorem, now in this particular triangle, right angle triangle, we can apply the Pythagoras theorem, and here the hypotenuse is C, is of length C, so C square is equal to AD square plus BD square, that is C square is equal to A minus X square plus P square. So it's like a fill in the blanks form. So C square is equal to A minus X square plus P square, okay. Now this a minus x the whole square, we can expand the expand it using the expansion formula, and that would be a square minus 2ax plus x square, plus again the fill in the blanks, it is p square within the column, and hence you mark this equation as 1. So this is one equation that you got. Next, in triangle ADC, now in this triangle which is in the right side, here also you have a right angle triangle. There if you apply the Pythagoras theorem, you can say now AC is the hypotenuse, so length of hypotenuse is b, so b square is equal to p square plus x square, that is b square is p square plus x square. Now here we need the value of p square, so p square we can be written as b square minus x square, that is equation 2. Now if you substitute this value of p square in equation 1, then you get the required equation actually. So substituting the value of p square from 2 in 1, you get c square is equal to a square minus 2ax plus x square. In place of p square you write it as b square minus x square. This is from equation 2 we get this, okay. So c square is equal to, now this x square minus x square will get cancelled. What will remain is c square is equal to a square plus b square minus 2ax, okay. Now c square is same as ab square, a square is same as bc square, b square is same as ac square, and 2ax means minus 2bc into dc. So resubstituting the letters by the sides, you get the required equation, okay. So this is what happens to the side, which is the relation between the side opposite to the acute angle and the remaining two sides, okay. Now let's see what happens when the side is opposite to the obtuse angle. Okay, so here we have another triangle ABC, and here angle ACB, this particular angle C is obtuse, and segment, hence we drew the segment AD perpendicular to BC, which is coming outside the triangle, because we had to extend this BC to get this perpendicular line drawn. Now whenever you find height of a obtuse angle triangle, this happens, and when base is like this, you have to draw the perpendicular line outside the triangle, okay. You extend the base and then you draw it like this. So that same thing is done over here, and naming is like opposite to angle C, so this is of length, this is named as letter C, small letter c, okay, and opposite to angle A, so this side is named as small letter a, and opposite to B means this is named as small letter, using small letter p. Next, in this particular triangle, this AD is named as P and DX is named as X, or DC is named as X. So in the figure, segment AD is perpendicular to segment BC. Let AD is equal to P, AC equal to B, AB equal to C, and BC equal to A, and DC is X. Now if DC is X, this particular thing is X, then this full line DB will be X plus A. This is understood. Now if you apply Pythagoras theorem to this bigger triangle ADB, here if you apply the Pythagoras theorem ADB, here AB is the hypotenuse, wherein AB is named as C. So C square is equal to A plus X square plus P square. So P square is one side, A plus X is the other side. So this is directly applying the Pythagoras theorem. Now using the expansion formula, you can expand this as A square plus 2AX plus X square plus P square. This is equation 1. Now choose this smaller triangle ADC, which is again right angled, and this AC is the hypotenuse. So here we get that B square, which is AC, B square is equal to X square plus P square, okay. Now from this we need this P square, so P square will go to the right, to the left, and B square comes to the right side. So P square is same as B square minus X square, okay. P square you kept it like that, X square you take to the other side, then you get this equation, that is equation 2. Now once you find the value of P square, this can be substituted in this equation 1. So therefore substituting the value of P square from 2 in 1, okay. So this particular equation from this particular equation, just like we did in the previous question. Here we add this equation for p square. This value of p square we substitute in this equation 1. Okay, so c square is equal to a square plus 2ax plus b square. Now when you are substituting, what happens in place of p square? If you write b square minus x square and x square will get cancelled. X square minus x square is 0, so that will get cancelled. A square plus 2ax plus b square will remain. Okay, now you resubstitute it. C is same as AB, A is same as BC, A is AC, B is AC, and AX means A is BC and X is CD. So like that you resubstitute the sides, you get the required equation. So when we had a side opposite to the obtuse angle, opposite to the acute angle, here you had a negative sign, and when you are having an obtuse angle, here you are having a positive sign, and BC, CD, those two things also change a bit according to the diagrams or according to the acute angle or obtuse angle cases. Okay, so these are the two relations we found for the side, between the side opposite to an acute angle or obtuse angle and the remaining two sides of a triangle. Okay, now so that's all with this video. So we just discussed the two applications of Pythagoras theorem. There is one more important application of it wherein we will use it to prove an important theorem called as Apollonius theorem. Okay, that theorem we will discuss in the I will discuss in the next video. Also few examples. So stay tuned guys. If you like the video, please share it with your friends and please subscribe the channel.